Thank you guys all for joining us today. My name is Michael Callahan. I'm the Chief Marketing Officer here at Salt. With me is Nick Rago, who's our Vice President of Product Strategy. We're going to talk today about our Agentic Security Graph. We're really proud of what we built, showing what your agentic landscape looks like. Nick's going to go through a couple of examples, how we got to it, and then actually demo the graph so you guys can see what that might look like in your world. In terms of topics, Nick, if you want to advance the slide one, we're going to go through and do an explainer on what are AI agents and how you should be thinking about them, the platform we have, the graph, as I mentioned, and then for all of you, for everybody that joined the webinar, we have a special offer at the very end for you. One last thing before I turn it over to Nick. There are buttons that you should have somewhere on your screen, depending on how you have it set up. There's a Q&A button. Please use that if you have any questions, comments for us. There's also a chat functionality. Chat sometimes you can use that if you want to talk to each other, or we will look at that as well. But mostly we're looking at the Q&A to see if there's any questions that we should answer. So with that, thank you again for joining, and I will turn it over to Nick.
Thank you, Michael. And again, good morning, everybody. I'm actually streaming to you live from actually the Boston area. Again, really honored to be able to talk to you all today and talk to you about this new agentic world that we're living in, what we're doing here at Salt to hopefully make, we'll be making all your lives from a security standpoint much easier here. Interesting what's happening right now in really the enterprise world. The attack space is expanding astronomically and exponentially quickly. I've been in the API space previous to this for the last 15 plus years of my life. I've worked on some of the biggest digital transformation projects all over North America. We were screaming about how large the attack surface was. The attack surface was expanding in large enterprises when we were doing a lot of those projects, and it's true. It was. What we're seeing right now is the pace, the expansion of the attack surface and microservices being created in this nervous system, supporting all these new agentic workflows that we're seeing be created in large enterprises, is really dwarfing what we saw during a lot of digital transformation projects that I'd worked on in the past. So it is very, very wild to see what's happening out there today. I mean, previously we were really focused on what does that attack surface look like? What's that? What are all the endpoints and what can an adversary see on the outside? Now with a lot of the agentic workflows, there's what are we building? What does this nervous system look like? What about the dependencies we have with third-party systems? But what is getting overlooked a lot of times is this. I don't want to use the words rat nest, but looking at this picture, that's what it looks like. It is. It is this giant fabric of APIs and MCPs and tools and capabilities that are being created on the inside of the walls. And I always tell people one of the interesting things about the world that we live in right now is that AI agents are now becoming essentially our digital employees. Right? We were so worried before about protecting the castle and putting the moat and lining up our defenses in front of or behind a drawbridge, but now the adversary or the consumer of a lot of the services that we want to protect are already inside the walls. And what does that mean? And what does that mean from a security standpoint, a security posture standpoint? The world has changed when we talk about AI over the last year and a half. Right, a year ago we were talking about the magic of the LLM and what that can actually do from an AI standpoint. From a security standpoint, it was very much about how do I protect this LLM? How do I protect the supply chain? What is the data that we're training it on? What is going into the ears of the agent and what's coming out of the mouth of the agent? How can I put guardrails around all of that and protect that as well? The big thing that's changed over the last year is now the agents can actually, there's arms and there's legs attached to it. The agents can actually push buttons and pull levers. And it's not just what the agent is saying, it's what can the agent actually do? What is the agent actually do? Am I comfortable with the capabilities of the agents that we're deploying in our enterprises? And, if we take this particular example here, where a simple prompt is, my order didn't arrive, can you cancel that and give me a refund? Now the agent has the ability to think, what tools are attached to me? I have access to this vast nervous system of APIs through the form of tools or MCP tools, and can actually now take action and solve this particular customer's request here. They didn't get their order, they want a refund. I'm getting access to the information that I need. I have access to the tools to cancel the order, and blah-de-da, it's all done. Now, that's great, but can an adversary take advantage of this? What about all the connective tissue that's attached to this? Can an adversary get access to those systems as well? Am I comfortable with the security posture of this sort of holistic agentic ecosystem that I've created just to do this really simple customer service request and response action? Now, when we take a look at the agentic ecosystem, I was talk to a lot of customers today about moving from just prompt security or LLM security to agentic security, and what does that actually mean? And in a lot of the organizations that I work with today, they're very, very much still focused on the prompts themselves and putting guardrails around the what's going into the ears of the agent, but what's going into the LLM and what's coming out of the LLM or out of the agent's mouth itself. And a lot of companies have become very good at putting guardrails around what's going in and what's coming out of the agents, again, the ears and the mouth. And from a prompt standpoint, what's good and what's bad and what shouldn't be there. So in this particular case that you see on the screen, how much money is in my savings account? You have $10,000 in your savings account. From a prompt security standpoint, if you're doing any detection and response actions against this looks completely fine, no issues here. But if you take a look at really what's underneath the agent, what is actually empowering the agent to come back with this information and tell you that you have $10,000 in your account, there could be a lot of moving parts here. There could be an internal MCP server, so that's connected to the agent. The agent has access to the tools all related to this MCP server, such as a user profile service. And back-ended by that, there's a nervous system of microservices supporting those tools. There's dependencies now with a lot of third-party MCP technology as well. So this agent could have access to, let's say, an MCP that's hosted in the cloud. Let's say that's something that's hosted by Databricks, and then there's a data lookup tool associated with that. A lot of agents that we see today aren't using MCP servers. There's tools calls directly from the agent orchestrator themselves through an API gateway, and they have access directly to, let's say, an inventory of APIs that are hosted internally inside of an organization. So if we take a look at this, what could actually go wrong here from a security posture standpoint? Well, a couple of things. What if that MCP server that the agent has access to that's up in Databricks has access to more than it should? What if it has access to the bank financials? Has nothing to do with sort of customer service responses or actions here, but vast array of information that it has access to that it shouldn't, based on the function of the agent, why it was created. What if the internal MCP server has hard-coded API keys inside the MCP server source code? Now that is a way for authorization override here, where the MCP server doesn't know what is the scope of what's being requested or who has access to what or should have access to what. What if we just saw this in the press not too long ago? What if a backend service that is part of this agentic workflow, what if that is wrongfully exposed? That we built this so quickly, didn't realize that we exposed this out into the internet and that somebody could get access to it if they knew the address of where this microservice is. A lot of the basic blocking and tackling that we're seeing in organizations as well, that you'd expect, things like having rate limiting turned on inside your AI or API gateways. We're moving so fast right now. We're seeing in a lot of organizations that, again, that basic blocking and tackling is not getting done. What if PCI data is actually being exposed? We're relying on an agent tool, calls an API, and that API has no authentication associated with it, and it's returning back PCI data. So from a GDPR, PCI, a regulatory standpoint, we're putting ourselves at risk there. The short of the story is that from an LLM security standpoint, traditional LLM security or traditional AI security standpoint, we looked okay here. But in this new agentic world where we have this vast ecosystem, as you're seeing here, supporting one simple prompt, there's a lot of heightened risk here. Again, there's a lot of avenues here where an adversary could take advantage of this particular agent or the agent ecosystem to really do harm. So with that said, how has AI security really changed? Well, AI security, again, has gone from sort of LLM or model security to what we're calling agentic security. And everything that we've showed you so far are all in play here. Do I know, what LLMs are in place or agentic bodies that we've put in place and the LLMs that they rely on? And everything associated with protecting the LLMs, as I mentioned before, from how it's trained to how it's being used. Do I know all of the capabilities that we are enabling in our environment that are attached to agents? What is it that an agent can actually do in our environment? And are the capabilities attached to the agent in line with what the scope of what the purpose of the agent actually is for? And then lastly is it doesn't just stop at the front door of the agent capabilities, let's say in an MCP server, for example, or a tool declaration and orchestrator, but the nervous system that sits behind it as well, the APIs themselves, right? And all that nervous system, those APIs, are we putting ourselves at risk? Are we still doing everything that we need to do to make sure that that attack surface is being secured in a proper way that isn't putting us at risk or introducing us to new risks? So I mentioned before, a lot of the focus has been on the LLMs and the model lifecycle and the runtime security around LLMs and models, and the two acronyms that we've been throwing around a lot over the last year has been AISPM and AIDR, right? This whole idea of governance of models, and with AISPM, the security posture around them and the training of it. And AIDR is the detection and response against model usage itself, right? So what's going into the model, what's coming out of the model. Are we protecting ourselves from things like, from a runtime perspective, prompt injections or jailbreaking or unsafe outputs that may be coming out of the model? Are we protecting ourselves and optimizing token usage, right? We don't want to go bankrupt because we're overusing an LLM. We don't have to. The change that's really happened, or the evolution that has happened, is, while that all is still important, is this notion of agentic security. And two new acronyms throwing out into the world right now is AGSPM, or Agentic Security Posture Management. What are the capabilities of the agent? So again, that agentic ecosystem that's attached to an agentic body. What are the capabilities of the agent, the MCP tools, the APIs, the data that the agents interact with? What's the security posture of it? Is it configured in a way that we're comfortable with from a regulatory standpoint and our own security best practices and guidelines? And then from a detection and response standpoint, I always compare this to where a lot of the AIDR technology is almost like what the WAF did for web applications or APIs in the past. AGDR takes it a step forward, a step beyond that. From a logic standpoint, what if there isn't a very obvious prompt injection in a prompt, but what if a prompt is crafted in a way that it induces some type of negative behavior downstream that we don't want? What if an adversary was actually targeting an MCP server or a downstream API or a tool interface connected to an agent? Do I have, if I'm just watching sort of the ears and the mouth of the agent, do I have the ability to actually see if any of those systems were getting abused or misused? So a couple of things that are important here when we talk about, before we get into the demonstration here, what you're going to see in the demo is us sort of fulfilling this notion of how to secure the agentic enterprise. We already saw this in a lot of the diagrams that I showed you before, this notion of that there's agents, LLMs, internal, external, third-party MCPs that are connected. We have internal, external, and third-party APIs that are all now dependencies on sort of agentic function. From a use case perspective, in securing all of this, discovery, govern, and protect, those key concepts are still very, very important. What is actually out there? What is in my agentic ecosystem? What are my agents? What are the LLMs in use? What are the capabilities of the agents and the data that they're touching? Do I have an inventory of all this? It's not enough just to see disparate MCP tools, let's say, inside of an inventory. I want to know how those tools are actually being used and what agents have access to them. From a governance standpoint, are we properly enforcing all of our security standards? And are we doing it not just looking at what's running in production, but do I have the ability to actually take that security standard and make sure that we're also enforcing it from the time a tool, for example, is being designed and actually coded? Do I have the ability to tell those coding assistants who are helping me generate sort of my first draft and all my production code now, what my security standards are, so that when I make sure that when they go through that whole life cycle, when they get to production, that they are going to be compliant? From a data security standpoint, are we pushing all of our data security practices and best practices and framework to this agentic ecosystem? Do I know what a tool is capable of doing? Do I know what data is actually coming in and out of the tool? Do I know how that actually transcends downstream to the APIs that are supporting it? And then from a protection standpoint, I mentioned this already before, the ability to understand, not just watching the front door of these agentic ecosystems, the ears and the mouth, I should say, of the agent, but do I have the sophistication to understand when there's some type of behavioral anomaly that is malicious in nature? Someone doing malicious reconnaissance against through, whether it be the chatting with an agent, or if an adversary is actually doing malicious reconnaissance against any of the backend systems that are supporting an agent. No longer today can we just assume that the adversary is on the outside. We have to assume that adversaries have access to all of the internal systems as well. So a lot of things that we actually have to do here to secure the new agentic enterprise. I wish I could say there's one place to capture all of this data and to make it really easy. Unfortunately, that's not the case. It really takes context from a few different places in order to really, really bring this all together into a really, really good agentic security program. The context really looks like this. First is you have to have a good understanding of what does an adversary actually see from the outside. If they were going to do external reconnaissance against us, what can they actually learn about? What can they learn about my organization, good and bad? How am I configured, going into our cloud systems, whether they be, AWS or GCP or Azure, or any of the agent builders that are out there, such as like a Databricks. How are those actually configured? What is actually out there from an inventory standpoint? Do I have the ability just to quickly connect to those environments and actually get a good understanding of the inventory and the configuration of the agentic entities that are out there? From a source code perspective, what can our source code repositories tell us about what we're building and what we have in production? We may have a policy that says, hey, MCPs, we're only going to be using the fast MCP framework. Is anyone else in the organization building MCP tools outside of that framework? Are we hard coding authentication access tokens inside of our source code? What is it that when we build a tool in source code, what is it that it's actually connected to? How many third-party dependencies do we have outside of our walls? And then last but not least, from a traffic standpoint, having the ability to understand request and response and all of the moving parts and the data that's going between, to get really a holistic view of how the agentic ecosystem is actually being used, or even one singular agentic body. Here at SALT, we provide context for all of this. We provide the ability to capture the context so that we can give you and facilitate all of the use cases that you're seeing here. Our external reconnaissance technology is something called SALT Surface. You point it at a domain. It'll actually do everything an adversary would do, from going to see if there's people talking about your domains, to going to open GitHub repositories, to Postman, to downloading a mobile application, or going to your website and reverse engineering to try to see if there are any API and agentic interfaces or MCP interfaces that are exposed to the internet. What are they capable of? What can I find out about it? And again, this is with you doing absolutely nothing, just providing a domain name to SALT Surface. SALT Connect is our ability, again, to point to the hyperscalers and the cloud environments that are out there. I mentioned Databricks before. It could be AWS as well. It could be other hosted platforms like a Kong Connect or MuleSoft. SALT Code is our ability to get into your code repositories and collect. We have over 45 different mechanisms of capturing traffic today to be able to give you the context to to capture a lot of the data that I mentioned before. Okay, so what is it ultimately we want at the end of the day? At the end of the day, we want the ability to have context. We want the ability to actually see the relationship. I don't want to know that I have 100 different MCP servers and 5,000 MCP tools just in my inventory or in my enterprise. That is very helpful. I want to have the ability to know what agents are connected to them. How is it being used? What is the downstream connectivity from those tools or these MCP servers to the other entities in my environment? How do I get all of this information and put sort of this agentic security lens around it to build what we're calling the Agentic Security Graph, to really sort of masterfully show you the relationship between all of these entities in one screen, the inventory of them, the security posture associated with them, the data that's flowing through them, as well as any runtime risks that you may be experiencing on any of the components that are attached here. Okay, so what we'll do next here is actually take you to the product itself and give you a little bit of a live demo of what the Agentic Security Graph looks like inside of the SALT platform. Okay, so for those that are familiar with
Nick,
SALT,
let me just remind everyone, because you're kind of switching gears a little bit. Just if you have questions, please use the Q&A or the chat. We'll look at both of those. As Nick's going through this, if something you wanted to dig into more or wasn't clear, just ask us. Yep.
Thanks, Michael.
Yep.
So for those that are familiar with SALT security, think of us as sort of the pioneers of the API security space. Again, it was a natural evolution for us to sort of extend the platform to this agentic security world. Again, as I mentioned before, just because the nervous system of all of this is 100%, nearly 100% driven by APIs. So again, our focus has been having organizations understand what that what that entity fabric, that API fabric, that agentic fabric looks like. But it's one thing to understand that, yes, there are a lot of different places that an adversary may get access to, and I need to know about them and have protections in place against them. But I mentioned before, we want context. We want the ability to capture all of these entities and understand, well, in the lens of sort of the agentic body or the agentic ecosystem, what are the relationships between all of these different entities? So what you're seeing on the screen right now is this is the Agentic Security Graph inside the SALT Security Agentic Security Platform. And a few different things that you'll be able to see here. You'll be able to see, I'm going to start with sort of agents connected to sort of MCP entities. So you can see, I'll start over here on the left with MCP entities that are being shown in the graph, attached technologies associated with them, any API endpoints or backend systems associated with them as well. You'll have the ability to understand risk scores. So any agent capabilities will all have a risk score associated with them. You have the ability to understand if there are any posture gaps. So these are any policy security posture non-compliance that is associated with anything that you see in the graph. And then an understanding to know, what am I looking at here that is actually handling sensitive data? So what we'll do here is we'll drill into a couple of these things here. So first and foremost, I'll kind of pick on a focus here on a Bedrock retail agent here. I'll click into it, and this particular Bedrock retail agent, we're seeing a few different things. One is we're seeing the MCP attached to it inside AWS Bedrock Agent Core. And we're immediately getting some pretty good context here. One of the interesting things about the platform is that, as you can see, AI is really a first-class citizen anywhere inside the platform. So as I click on this MCP, on this agent interface and get access to information about the MCP tools attached to it through Agent Core, you'll see that we have something onboarded here called Pepper AI. This will give you immediate context over what is it that this particular element is responsible for. So here we're seeing, hey, the MCP attached to this agent, it's responsible for retail operations. So it takes all of the information that it's captured around, again, all of the entities, even downstream entities, and brings this up at a high level for you so that you're not here clicking around for 20 minutes trying to understand, well, what does this agent do? What does the MCP tools attached to this agent actually do? And how do they actually work? Here we can see again another list of sort of the connectivity or the capabilities attached to the agent. And if I click on one in particular, you'll get even a further breakdown. And this breakdown will actually show you the full chain of connectivity from the agent to the MCP server to the tool to the downstream API that the tool actually relies on. Okay. Here I'm focused on this customer profile tool. Again, have the ability to see the AI-driven description here, have the ability to understand any risk factors associated with it, what data is actually being sent in the request and the response related to this tool. Are there any posture gaps associated with it? In this particular case, there's one that's under the GDPR policy category that's letting us know that, hey, we have a prohibition of social security numbers in any MCP tools, and this particular tool has has a social security number coming back in it. Okay. If there was an attacker associated with a runtime threat, you would see that there, and then again a lot of details, including cloud identifiers or any system identifiers where this particular tool is running. Now, I'm kind of focused on the tool. We could do the same thing with the downstream API itself to show you what we know, what we see about this particular API. We can see this tool is actually attached to a GraphQL query. And again, clicking into this would bring the same interface showing us the risk factors, data, posture gaps, and any known attackers and details associated with it. So this is a really, really unique view inside the platform, again, or I'd say inside the whole sort of agentic security world, and that it gives you the ability to really understand an agent, its capabilities, and all of the downstream connectivity related to that agent.
I'll add one thing into that, Nick, is one of the things we saw, like Nick showed you the description, that we use our own AI called Pepper to explain like what an MCP server does or what an API does. As obvious as that may seem, it's impossible to keep all of this straight in your head. And when we show that to people, most people kind of breathe this sigh of relief going, okay, I don't have to remember all this does. I can quickly get access to what was this MCP server supposed to do, or what was this API supposed to do, or was in a natural sort of normal person description rather than like technical, deep technical description of it. It's a great feature. That's just part of it. You don't have to pay for it at all, but it comes with the platform.
Thanks, Michael. Yeah. So we kind of looked at sort of an example in the AWS world. What about building in other places? Let's say we're building agents and agent interfaces up in Databricks. You have the ability to actually do the same thing here. Again, what is it? What does an agent actually connect to? What are all the tools associated with it? What is sort of the downstream connectivity of those tools? Data, risk factors associated with that as well. Same can be done with source code. So this is an example showing us that we discovered an MCP server in source code. We were able to understand sort of the tools based on how the source code was written. The other interesting thing here is not only were we able to actually see the tool itself and essentially the API that's being called, on the right-hand side here, you can actually see that we're correlating for you the fact that, hey, we've seen this particular API. It's actually being served in the environment through a COM gateway. And so now, again, part of the magic here is being able to actually capture what we're seeing in source code and then lining it up to what is actually running in production. So you get, again, that cohesive context of understanding of, from when a prompt comes in and an agent takes action, what is actually being lit up in the back end that's associated with it. And am I comfortable from a security standpoint about, all of the elements that this particular agent is dependent on. Okay. So again, this was a quick overview of the Agentic Security Graph. On the graph here, you're seeing, I've shown a couple different examples of, these risk scores and posture noncompliance. I gave the example of, social security numbers coming back in an MCP tool response. So where is that actually coming from? So inside the platform, we have a policy governance engine. The policy governance engine is over 100 different policies out of the box from in all sorts of different categories. also has a policy builder that you can actually build your own custom policies. And here you may have a policy that says, hey, user IDs have to be in UUID format. That is just the policy here. It doesn't matter if it's an MCP tool, an API, or anything in between. That is something that we want to enforce here. So this gives you the ability to take not just your regulatory requirements and industry best practices, but whatever, when your governance committees get together and they make all of the rules of what developers and architects should do when they're building sort of agentic systems, whether they be MCP servers, tools, the agent orchestrators themselves, or the downstream APIs in the nervous system that everything is attached to, you can make sure that those security standards, those corporate security standards, are being followed. And again, we're ensuring it obviously in the runtime piece, but also when we are looking at code or integrating with coding agents, have the ability to enforce those standards there as well. I showed you the posture gaps in kind of overlaid inside the Agentic Security Graph. You also have a interface specifically dedicated to posture gaps themselves. So again, here's a PII exposed without authentication in an MCP server. One of the great things what we have the ability to do with this is you can integrate this with any workflow. So this could be Jira, ServiceNow. We provide the context, to help facilitate the utopian world where we see non-compliance. We give context, to the connected ecosystem like a Jira or ServiceNow, who could be connected to a coding agent, and that coding agent says, "Hey, you know what? This is how we can fix it." You wake up the next morning and the pull request is already waiting for you. Lastly, here is Salt Protect. So everything that we've showed you, that I showed you earlier in the Agentic Graph. Let me go back here. We have the ability to, again, not just watch what's coming through the front door, but we also have the ability to behaviorally analyze what is going on with everything that's downstream to sort of, again, the ears and the mouth of the agent, the connected MCP servers, the connected backend APIs or direct API tools, or even usage of third-party systems, as I mentioned before, like a Databricks. So what our technology does is it looks at and monitors all usage on all of these systems, and then will discern if it sees an anomaly, whether or not that, through going through three layers of AI, it'll determine whether or not that anomaly is something malicious or not. And the detail and the level that it goes to do this is pretty quite extraordinary. In this particular case here, we're seeing a behavioral anomaly. And let me just break this out a little bit. And it's actually showing us two things. It's actually showing us that, hey, it looks like the same user is actually getting employee data through an employee, an HR interface here that looks like it's exposed to the internet. So immediately the system called out that, wait, it looks like there's 14 values coming back. We're going to block this user. But the other interesting thing is the system also detected that, well, wait, there's a difference in scope. We know that when the HR systems are called, it actually uses an HR.supersurplus.store scope. This one has an API. That means that we have an authorization problem as well. For whatever reason, the HR system is allowing the e-commerce tokens to get access to this to the HR system as well. So going down to that level, the system is intelligent enough to understand when, when there's a behavioral anomaly, the repercussions of that behavioral anomaly, and whether or not the anomalous behavior attached to it was adversarial, if it was malicious in intent. And this will integrate with all of your traditional runtime technologies that will go to your SOC and your SOAR, regardless if you're using a CrowdStrike Next-Gen SIEM or a Splunk. It will integrate and have the ability to block with any blocking agent that you have in the ecosystem, whether they be a WAF, a WAP, an API gateway, an identity provider. You'll have the ability to sort of shut the door on the adversary upon detection. So that was a lot of quick talking and in the demo here. What I wanted to do is kind of just open this up to questions.
I'll answer a couple, or I'll read a couple. I think there's one specific for you, Nick. But one of them was someone had asked, are there frameworks that, you guys hear an echo on that?
No.
Okay, maybe it's just me. Any frameworks to follow? And I think what's interesting is there really isn't an accepted framework right now for agentic AI, although I have seen NIST is doing some work in there. It's very early. There is a little bit of this. It's not quite frameworks, but that's the MCP, right? That's an array to A. That's a kind of a like, here's a protocol we might use. One that I'm seeing develop even more, and it's more specific to the EU, but I think if you're doing business in the EU, you may have to adhere to it, but it's the EU AI Act that goes into effect August 2nd of this year. That's a pretty big one. It's not a framework as much as it's like a compliance policy or guideline. We can help a lot with that. There was another question about attacks. I think Nick answered that when he showed this a second ago. If he didn't, whoever asked that, it says it was anonymous. Maybe ask it again. And then one for you specific, Nick. I don't know if you're looking at this or not, but it was how easy is it to build custom policies? What technology is involved to do that? That's a good one for you, probably.
Okay, great. Yeah, just to recap on all of them from the framework standpoint, everything that you just mentioned, we're seeing people kind of adopt playbooks from MITRE. A lot of this is still in motion. We see, OWASP has put out some, security guidelines as well. We've already seen like the OWASP LLM security top 10. There's a bunch of MCP security best practices or top 10s that are in draft right now. So there's a lot of that in motion from a best practice standpoint and framework standpoint. One of the nice things is you can adopt with this particular technology, you can adopt a lot of those policies inside of the platform and know when you're sort of breaching any of the guidelines associated with those framework or those policies derived from those from those frameworks. On the 0-day and the attack standpoint, one of the nice things about the behavioral threat protection is that it doesn't rely on any particular signature or pattern. So a lot of times you have to know about the attack in order to recognize the attack, in order to stop the attack. One of the great things about behavioral threat protection and how we do it here is we baseline what's normal. And so if it's a 0-day, something that we've never seen before, what the system will do is it'll see what is the behavioral change that's actually going on, and is the change doing anything that's putting me at risk? If I'm seeing sensitive data move, start to be requested in a clip that we've never seen before, for example, in ways we've never seen before, then that would be high risk or critical, and the system could block or it'll alert based on that. So even before, a WAF or anything anything related to that relies on signatures or patterns, knows that a particular attack is a 0-day attack is surfacing, we have the ability to surface it up as a behavioral anomaly and a behavioral anomaly that is putting you at some type of risk. And I'm sorry, the last one was, what was the last question, Michael?
About building custom policies. How easy is it to build?
Yeah. So inside the platform itself, I kind of showed you before, we do have a policy builder here where you can create your own custom policies here. It's all, compound conditionally here. So any context that we have, any technology, so you could say, find technology. If it's an MCP server and a tool, a tool should never be exposing anything that is GDPR related, outside of our walls. Or I need to be using a particular authentication scheme. All of our tooling should be using, OAuth, and nothing should actually be using key-based authentication or basic authentication. So again, I'm not going to go through the whole list here, but any context that we capture, you have the ability to build conditions on through here. And as I mentioned before, all of these policies, while we're kind of keeping score for you in production here in terms of in runtime, whether or not you're following them, you also have the ability to actually educate all of your coding assistants and any coding agents in your CI/CD pipeline of all of the policies that are in here as well. So if it's important to monitor in runtime, you can educate all of your coding agents in your pipeline to make sure that they are also enforcing the same policies that are being enforced here.
I'm going to add one more comment to this, Nick. Maybe you could look at there was a question about baseline behavior. You can be thinking about that as I answer this question. But this goes back to the policies. Nick showed it a little bit. I don't know if everyone understood just how big it was, but there's about 100 pre-built policies. Think of it as like an app store for policies, where it's based on what we've seen across our hundreds of customers, what they actually just write out 100, exactly 100. And it's a super easy deployment of it. So these are ones that like you should be able to just go in and say, oh yeah, that's right, that's my industry, or I need that, and you just click it and it gets deployed and the posture or the policy is activated. There's 100. Again, it's like an app store for policies. Those are all out of the box and they're ready to go. If you want to do custom ones like Nick showed, it might take you 30 seconds, 45 seconds to build your own custom one if you want one that's not in these that we've already done. Okay, so the question for you, Nick, was about baseline behavior.
Yep. Yeah. Just saw Reginald had asked. So Reginald, the way it works inside the system is obviously the longer we are looking at traffic, the more extensive the baseline is. But one of the interesting things about the technology is in a behavioral threat protection is how we actually do the modeling is really it uses a lot of big data sets. It's so large in terms of the number of models that we're using and the baselines that we're that we're comparing to, that you can't actually run it on-prem. It would just be cost prohibitive from you. So what I mean by that is if we have the ability within really within, it's less than an hour. Technically, it's much less than that, but let's say it's an hour. Once we're watching traffic, we actually do modeling per request, second, minute, hour, day, week, month, and beyond. So again, as we fill up those windows of time, we have the different levels of baselines that we're creating, or the parameters of baselines that we're creating. So even within, technically within, under an hour and a matter of minutes, we're actually establishing the first baselines of what's normal, looking at all of the traffic. So it really doesn't take long at all.
There's another question about pricing. Thanks for asking that one. So we have 3 different pricing, Standard Pro and Enterprise. And it's largely based on the number of APIs, but it's also what functionality you want in it. So there's the AGSPM, which is the posture piece. And then in addition to that, you could buy the detection and response, or the AGDR. Again, it's typically by number of APIs, but it's also feature-based. So if you're interested, we'll find the package is right for you. Just talk to your account executive, and they can help you find the one that's the right one for you. There was a question about why didn't we make any salt and pepper dad jokes? We were afraid that we would get pelted with virtual tomatoes if we did that, so we just refrained from any dad jokes. And I think you answered this last one right already, Nick, about the baseline. How do you train it? I think you already answered it. So let me give everybody one last option, or one last to send any questions in. So any chats or questions that you have, let me know. We'll keep monitoring this for the next few minutes. Okay, otherwise, let me get us start to wrap it up. So thank you guys all for staying to the end. It seems like barely anybody dropped off, which is great. Nick showed the product. Wanted to highlight a little bit. Many of you have access to Gartner if you're enterprise companies, but most people have access to this anyway. Hey, Nick, could you mute yourself for a second? I think that's maybe where the echo I'm hearing. So here you can go and find this research out. Gartner puts it together, but it's very much, it talks about the widespread adoption of MCP and ATA and how you're going to have even more and more API usage. They recommend doubling down. This is a little bit outdated on API security, because API security essentially has become AI security. That's that middle column I'm talking to. And how important it is for people to manage a shift from securing prompts, which Nick talked about that at the very beginning, about securing the prompt, which is where a lot of the focus has gone to. How do you secure the rest of this? Which the prompt is really like the tip of the iceberg. Most of the risk, most of the action is happening beneath the prompt layer, where we showed you how that looks. Nick, I think, showed like, oh yeah, you could have secure prompt and everything comes back fine, but you've got all these other risks beneath the surface of that. So take a look at Gartner. You should all have, well, if you do have access to that. If you don't, you can send us a note and we will we'll get you the links to it or the information from Gartner. And I see one last chat in here. So there's a question about the recording. Oh yeah, Danielle already answered. Yeah, recording in the next 24 hours. Nick, if you want to go to the last piece. So this is the graph. It's the same what Nick had showed. if you click on that QR code, it'll take you right to the security graph where you can put in your name, put in URL, and we will do this for you. We will scan your environment externally only. We will not do anything internal. This is exactly how an attacker would see it, and we'll start to build this graph for you. So you can see, at least from the outside view, like what's visible, what risks do you have, what should you think about. It's usually super enlightening for people when they see this. Again, it's almost impossible to keep this all straight in your head. But when you start to see it visually, you kind of get the scope of what's going on with all of your agents and how widespread it is. If you don't want to use a QR code, you can just go right to the link, which is there on the slide if you want to type that in, or you can just go to the website, salt.security, and you'll see a link to there as well. Okay, that is it for us. We finished with a few minutes to spare. Thank you all for hanging in there for the whole webinar. If it will be available, we'll send it to you within about 24 hours. Nick, thank you as always for leading us through this, and everyone else have a great rest of the weekend. Thank you again. If any more information, best place to go to is salt.security. Thank you.